You probably think you have a decent grasp of how the world works. So that physics is one of those things you learned in school. Complicated, sure, but logical. Well, maybe not. Today, we're rediving into 10 things about physics that simply don't work the way you think. Some of them flip your intuition upside down. Others make it feel like we're living inside a glitched-out video game. But one thing's for sure. Every single item on this list proves that reality is way stranger and more fascinating than fiction. So buckle up, because this journey will blow your mind. And if you think you've seen it all, just wait until number 1. Number 10. Gravity isn't actually a force. You grew up learning that gravity is a force that pulls things down. Drop a pen, it falls. Jump, you come back down. Simple, right? But according to Einstein's general theory of relativity, gravity isn't a force at all. It's the curvature of space-time caused by mass and energy. Picture placing a heavy bowling ball on a trampoline. It sinks into the fabric, bending it. Now roll a marble across the surface. It curves around the bowling ball, not because it's being pulled, but because the surface itself is warped. That's gravity. Objects following the straightest possible path through a curved four-dimensional space-time, and what you feel when you're being pulled toward the Earth. That's actually you trying to move straight, but the path itself is bent downward. Your feet hit the floor not because Earth is pulling you, but because space-time is telling you to fall. Even light, which has no mass, bends around stars due to this curvature. That's why we can observe distant galaxies distorted by gravity in what's called gravitational lensing. Gravity doesn't tug, it guides, and our entire concept of up and down is completely relative to how space itself is shaped. Still sounds simple? Didn't think so. Number 9. Time isn't absolute. You've probably heard the phrase time flies. But what if I told you time literally flows at different speeds depending on where you are? According to Einstein, time is relative. If you're traveling near the speed of light, time slows down for you compared to someone standing still. This has been proven with atomic clocks flown on planes. Even altitude changes things. Time ticks faster at the top of a mountain than it does at sea level because of gravity. In other words, your clock is never perfectly in sync with anyone else's. So next time someone says you're late, you can technically blame Einstein. Number 8. Solids aren't actually solid. Ever stubbed your toe on the corner of your bed and thought, wow, this is really solid? Well, not exactly. Most of what we call matter is actually empty space, the atoms that make up everything. Your bed, your foot, your phone are mostly just clouds of probability with tiny nuclei in the center. And those electrons, they don't really touch each other. What you feel is solid is actually the repulsion between electromagnetic fields. Meaning, you never really make contact with anything. That pain in your toe, caused by something you technically didn't even touch. Number 7. Empty space isn't really empty. You probably imagine outer space as a perfect vacuum. A cold, silent void. But surprise, the vacuum is buzzing with activity. In the quantum world, particles and antiparticles pop into and out of existence constantly, like the universe is flickering. It's called quantum vacuum fluctuations. This empty space is actually filled with energy, which ties into concepts like dark energy. So the next time you look up at the night sky and picture peaceful nothingness, remember, even nothing is noisy. Number 6. Light can be a particle and a wave at the same time. This one sounds like a bad science joke. Light is a wave, but also a particle. At the same time, it's called wave-particle duality. In some experiments, light spreads out like a wave. In others, it acts like tiny packets called photons. The wildest part? The famous double-slit experiment shows light behaves differently depending on whether it's being observed. That's right, just watching it changes the outcome. It's like light knows it's on camera and decides to act differently. Spooky totally. Awesome. Absolutely. Number 5. Inertia isn't just laziness. We're taught that objects at rest stay at rest, and objects in motion stay in motion, unless something gets in the way. It's inertia, right? A kind of built-in stubbornness of matter. But almost no one asks the deeper question. Why does matter resist changes to its motion? What gives mass this mysterious property? According to classical physics, it's just how things are. Modern interpretations dig deeper. Enter Mach's principle, a radical idea suggesting that inertia arises not from the object itself, but from its interaction with all the mass in the universe. In other words, when you try to push a chair, you're not only dealing with the chair's mass, you're feeling the cumulative gravitational effects of stars, galaxies, and dark matter spread across billions of light years. The entire cosmos might be weighing in on that simple action. Even more wild? Some physicists believe that inertia could be a kind of delayed response from the gravitational field of the universe itself, bouncing back at you. And then there's quantum field theory, which hints that inertia might result from how particles interact with fields like the Higgs field, the same one responsible for giving particles mass in the first place. So next time you're struggling to push a heavy object, don't blame your muscles. You might be wrestling with the entire universe. Number 4. Electrons don't exist in a specific place until you look. You probably imagine electrons as tiny balls orbiting an atomic nucleus, like planets around a sun. Wrong. That model's outdated. According to quantum mechanics, an electron exists in a cloud of probability. It could be here, or there, or everywhere. It doesn't collapse into a single location until it's observed. Before you measure it, it's not anywhere specific. It's pure potential. It's not science fiction. It's science fact. Reality literally waits for you to look before making a decision. Number 3. Matter and energy are literally the same thing. Everyone knows the equation. E equals mc. It's printed on t-shirts, coffee mugs, and high school posters. But most people don't really understand what it means. This isn't just a cool formula. It's a direct statement that mass is energy, not related to energy. That can become energy. It is energy. It's matter in its most fundamental form is just a super concentrated bundle of energy held together by the laws of physics. That's why even a tiny amount of mass can release an unbelievable amount of energy. Think nuclear bombs or the power of the sun. In nuclear fission, splitting atoms releases a fraction of their mass, and that sliver transforms into explosive energy. In fusion, lighter nuclei combine into heavier ones, with leftover mass again becoming raw power. But it gets crazier. In particle accelerators, scientists slam particles together at near light speed, turning matter into pure energy, then back into entirely new particles. It's like recycling the building blocks of reality. This equivalence also means that energy itself has weight. If you charge a battery, it weighs more than when it's dead. Every object you've ever touched is just vibrating energy frozen into form by quantum fields. Your hand energy, your phone energy, your thoughts. Yep, electrochemical energy. You're not made of stuff. You're made of motion. You're a ripple in the universe's endless dance of energy. Number 2, you're moving thousands of miles per hour. Feel like you're sitting still right now? Laptop in front of you, maybe a drink nearby. Sorry to break the illusion, but you are blazing through space at a speed that would make a rocket ship blush. Let S start local. Earth spins on its axis at about 1,000 miles per hour if you re-near the equator. But that's just the beginning. Our planet is also orbiting the sun at an insane speed of roughly 67,000 miles per hour. And the sun itself? It's whipping around the center of the Milky Way at about 514,000 miles per hour. But wait, it doesn't stop there. Our entire galaxy is zooming through the universe. It's pulled by cosmic structures like the Great Attractor, speeds exceeding 1.3 million miles per hour. That means in the time it took you to hear this paragraph, it's traveled tens of thousands of miles. Without lifting a finger, why don't you feel it? Because motion is always relative. You, your chair, the building you're in, they're all moving together at the same speed. There's no wind, no shaking, no signs of this cosmic cruise. It's like being in a plane flying at cruising altitude. You can walk around, sip a drink, watch a movie, and it all feels perfectly still. But that stillness is an illusion crafted by physics. In reality, you are strapped into the fastest, wildest ride in existence, and there's no getting off. Number 1, the universe might be a simulation, all right? Buckle up, because this one sounds like science fiction, but it's got some serious scientific backing. The idea that we might be living in a simulation used to be the stuff of movies and conspiracy theories. But now, some physicists, cosmologists, and even tech billionaires are taking it seriously. Quantum mechanics reveals bizarre patterns, particles that exist in multiple states until observed, seemingly random outcomes governed by probability, and limits to how precisely we can measure the universe. Then there is the Planck length, the smallest measurable unit of space, which suggests the universe might have a minimum pixel size, like a screen. Add to that the discovery that information not matter may be the most fundamental building block of reality. Some theories even propose that space-time itself could emerge from quantum bits, just like computer simulations are built from binary code. And if the universe is governed by math and logic in such a clean, computable way, who's to say it isn't actually being computed? Maybe the speed of light is just a processing limit. Maybe black holes are data sinks. The kicker: there's no experiment yet that proves we aren't in a simulation. Physics doesn't confirm it, but it doesn't deny it either. So ask yourself, if this reality is running on some cosmic mainframe, who wrote the code? Are you the player, or just a very well-rendered character? So ... how many of these physics facts shattered what you thought you knew? The universe isn't just strange. It's way stranger than we ever imagined. And we've only scratched the surface. Your brain's still processing all of this. Good. That's exactly what science should do. Challenge, confuse, and inspire. If you want more mind-bending topics like this, make sure to hit that like button. Subscribe for weekly drops. Ring the bell so you never miss a twist in the fabric of reality. Got a favorite theory or a physics myth you want busted? Drop it in the comments. We might feature it next time. Until then, stay curious.